All right, problem 7.7. Bear with me on this one. I don't have the answer yet. So, consider a 50 gigabecquerel points isotropic source emitting 1 MeV photon per transformation. The source is to be stored in a lead cask. What minimum cask wall thickness is required to assure that the exposure rate at the outside surface of the cask is limited to 2.5 MR or 2.5 MR per hour? This is our constraint. First of all, neglecting buildup factor, and second of all, accounting for the buildup factor. So for this one, we have to consider a worst case scenario where we have some cask like this. This is a section view of it. And let's just consider having the source right up against the wall. That's worst case scenario. It's the closest to one wall. So this thickness right here is what we're interested in. And this is where we're measuring this 2.5 MR per hour. Does it say anything about the wall or the cask dimensions?
No.
No.
Okay, alright. Sweet.
That's the second assumption.
So first we're going to find the source strength first, because they give it to it in giga becquerels. So it's just going to be 5 times 10 to the 10 photons per second. And these are 1 MeV photons. Now we need to find the uncollided flux going on in here at this point. So the uncollided flux at this point is going to be the source strength over 4 pi t squared e to the negative mu t. So phi is equal to 5 times 10 to the negative 10, 4 pi t squared e to the negative mu t. And what is t? We don't know, that's what we're finding. So we need to find how our constraint fits into all of this. So we want that the exposure outside, exposure rate outside is equal to 2.5 MR per hour. Well, if we're not accounting for buildup, then this is uncollided exposure. And uncollided exposure is equal to the response. How's that? Yell at me if I do this wrong. Is equal to that, right? Or before, exposure is equal to the response times the uncollided flux, or the uncollided exposure. And so if we say that 2.5 MR per hour is equal to R of X, and what's exposure for this? I have actually this written down.
6.944 times 10 to the minus 7.
Whoa.
Oh, I thought you just wanted to convert that to per second.
Oh, okay.
Okay, never mind.
All right, sorry.
I wasn't paying attention.
I was talking about this one.
Oh, 0.5118.
0.51. All right.
Oh no, not for lead. That's, oh, never mind. It's always there. I always forget.
Aha. So this is R centimeters squared. This is feet. Okay, so this is 0.5. So yeah, you have to convert this to second. And what was it?
6.944 times 10 to the minus 7. Minus 7.
Minus 7?
Yep.
Okay.
R per second.
R per second?
Yeah.
So here you can find that your flux is constrained to 1356. Is that what you got?
I didn't calculate that.
Can somebody calculate that? I want this 6.9 10 to the negative 7 divided by 5.118, or 0.5118 to negative 9. Just want to make sure that's right.
Is that 6.9?
6.9 10 to negative 7.
Okay.
Yeah,
0.5.
1356.
Okay.
Point.
So this is the maximum value for our
1348.
flux.
Yeah.
What?
If you use 6.944,
yeah.
you get that.
Okay, so
If you don't
this is about
approximate
right.
it, right.
Yeah, so this is about right. Order of magnitude.
Yeah.
Um,
That's how you grade our paper, right? Or our homework, right? Order of
Hey,
magnitude.
if the process is correct and the answer's wrong, then you miss like 1 point, and just say process right, answer wrong. So now we have this. This is our maximum flux. This is our constraint flux. So we set this equal to 1356 per centimeter squared per second is equal to this value, this equation here. 5 times 10 to the 10, this is positive 10, not negative 10. Write that bigger so you can see it. Over 4 pi t squared e to the negative mu, which is 0.7823 centimeter negative 1 t. And we have this one we're looking for this, and I don't know if you can solve this by algebra, so you just set it equal to 0. It's equal to 5 times 10 to the 10 over 4 pi t squared e to the negative 0.7823 t minus 1356. Find out thickness. Plug your calculator. If you don't have a TI-89, you do it this way. Say y equals 0. Find the intercept, and you find that t is equal to 12.57 about. Minimum thickness of the cask. If buildup is not included. So now we have to account for buildup, and this is where I messed up in my problem. So now we have to find the buildup, or the new flux. So flux is going to equal, this is a point source, our distance doesn't change, we don't have to integrate anything. So put our source strength over 4 pi t squared e to the negative mu t times the buildup factor at our energy times mu t. Now t is not changing, t's are variable, or unknown, but it's not changing with respect to anything. So this is a constant, some constant unknown. So we're going to plug in Berger approximation for it, because Berger is a nice, easy approximation to use algebraically. 1 plus a mu r e v mu r. This is for lead. And
we want those r's 3 t's.
Yeah, thank you.
Just make sure.
Where a is equal to 0.3, b is equal to negative 0.015. Now, I made a mistake in my homework when I did this. I said our constraint is 1356. That is wrong, because over here we got that number from this exposure, right? So I think it's about to get ugly.
Wait, why?
What?
Why isn't that right?
Why is this not right? Because we're not looking for the uncollided exposure. Right now we're considering
Oh, because
buildup.
you already found the flux.
So this
Okay.
has to be less than or equal to 2.5 mR per hour.
Yeah.
And exposure rate is equal to response times phi, or not phi naught, or times phi, which this is equal to response times phi naught times the buildup factor.
X dot equal or less than what this sign?
This is less than.
Why?
This is our dose that we're giving the. Our dose has to be less than this value. That's what I'm saying. Our dose. This is our dose. Our exposure.
You mean the new dose should be less than this value?
Yes.
I think
That's just in the problem statement.
you mean the dose should be constant.
Okay, so the dose.
Well, yeah, we just solved.
We're
We
gonna,
want
we're
the
gonna
dose
set,
to
we're
be
gonna set this
constant.
equal to that.
The fee will reduce, will be less, because you know we have x dot equal r fee, right? R fee b in this situation. So
Okay,
once
go ahead.
we want x to be constant, x dot to be constant, and once b is greater than 1, so
B will
fee
be smaller.
should be
Yeah,
lower.
that's where I messed
Right?
up, that's what I'm saying. That's where I messed up, because I said that if this is the same constraint, it's not the same constraint. Now, now our constraint is fee will be set equal to, okay, does everybody see what this is? Alright, everyone's craning their head, let me these up here. Because our exposure is equal to phi times the response, or this response function, this phi can be broken down, can be approximated by phi naught r, or not phi naught r, phi naught b times rx, right? Everybody okay with that? So now our constraint is phi has to equal x over br. Is everybody okay with that? Okay. So let's set these two equal to each other. So let's just see what happens here. S over 4 pi t squared e to the negative mu t, and I'm gonna just write this as b again because I'm just gonna see what happens. Okay. Putting it back in the other way. 1 plus a mu t e b mu t squared. Get rid of this. Everybody okay with that? Yes. Good call. Yeah?
When you write your exposure is, and you have it with the build-up factor in it, that phi naught, that's still your dose, or that's still from the uncollided photons.
Mm-hmm.
So
why can't we use that?
What?
Why can't we use that?
No, I know why we can't use it in where you have x equals phi times the response function, but that is for all the photons.
You're right.
So that phi naught there can still be your 1356 times phi all.
Good catch, good catch. So let's do it this way then. Our total flux is equal to x over rx. Now let's set this equal to each other. Good catch. Okay. And now we can do the solution. If you don't have a TA89, you're gonna do it this way. You need TA89 people. And we find that T is equal to, what is it? 14 point something?
13.99.
13.6.
It's about 14, 13.9, 13.9.
Okay, I have written in my homework that I got wrong 14.5. So let's plug in numbers and see.
I got 13.99. So.
Yeah, 13.6.
Alright, let's find out. So 0 is equal to, what is it? 5 times 10 to the 10? 4 pi t squared e to the negative, what is mu? 0.78 2 t 1 plus. Hey, we gotta break this up.